Hello, welcome back to another lesson with Ming, and today we're going to continue our exploration with exponents, and our learning target for today is I can explain the meaning of a to the power of m, everything raised to the power of n. Alright, here is our learning target. Now let us start by considering this particular problem, that is b cubed and everything raised to the power of 2. Well, what does that mean? Well, we know that everything raised to the power of 2 means everything times itself twice. So I'm going to put then 2 bracket times itself twice, and within the bracket is b cubed. So it's b times b times b in one bracket, and another bracket is b times b times b. Now I can simply count how many b's are there. Well, you will find that that is just b raised to the power of 6. Now I'm going to consider another questions. A square, everything raised to the power of 4. Well, that going to means that I'm going to have 4 brackets. And in each of these brackets, I'm going to have a times a square. So now I count. How many a's do I have? Well, that will be a 8 times a raised to the power of 8. So at this stage, let us make an observation. Well, what is the connection between 3 and 2 and this number 6 over here? 3 and 2 and 6. Very good. We can have b to the power of 6 can be written as b 3 times 2. Alright, and how about 8? And 2 and 4, that is what links 2 and 4 with 8? Very good. 2 times 4 is 8, so a to the power of 8 is basically a 2 times 4. So now, can you see a summary from this observation? Or you can come up with a conjecture. That conjecture is a statement that you make, a guess that you make based on observation. So I probably will make a conjecture like this. If I have a to the power of m raised to the power of n, then the conjecture would be very good. A m times n. Now let us check to see whether this conjecture is actually correct. So let's check by having, alright, let us have b to the power of 5 raised to the power of 3. Okay, so that will be 3 brackets, and then within there I'm going to have 5b, b times b times b times b times b, and this is what I get. This is exactly the same. b 5 times 3 is b to the power of 15. Alright, welcome back, and let's check your answers. This 8 square quantity raised to the power of 3, that will be 2 times 3 in the index. That will be just a raised to the power of 6. Very good, if you have got that correct. The second part, that is b 4 times 3, that will be b raised to the power of 12. Do you get that correct? Excellent. The next one is d raised to the power of negative 1. Remember that? What does that mean? Very good. 1 over d, exactly. So this is d negative 1 times 3, or just d to the power of negative 3. Alright, and you could have done that slightly differently like this. 1 over d raised to the power of 3, or 1 over d cubed. These two are exactly the same. And the last one, the d part, is d 3 and times negative 1. Well, that is also d to the power of negative 3. And for this, you could have done it slightly differently. That is using, well, 1 over d cubed. Right? And that's it. That's the answer. Alright, what is a to the power of m raised to the power of n? Well, that is, as written here, that is just a m times n, or mn. Over here, f. How about an raised to the power of m? Well, that is a raised to the power of n times m. But what do you observe? Well, both of them are actually the same thing. A mn equal to a to the power of nm, because in multiplication, m times n is equal to n times m. So if you were to, your friend asks you, what's the relationship between a to the power of m raised to the power of n and a to the power of n raised to the power of m, then it has to be the same. I hope that you have enjoyed this lesson, and by this stage you were able to explain to another friend what it means to have